Our next speaker is going to explain how to build application security from the ground up with little to no budget. So it's my pleasure to introduce Musheg Hakinian, VP of Security Architecture at Interlinks.
Thank you. Hi, everyone. Good morning. Thanks for coming. I know that there are lots of great presentations going on, and it's very tough to follow Dimitri, but I'll try. So a little bit of introduction of what we do, what's Interlinks doing. Actually, we're a content sharing platform where people who are doing financial transactions, usually mergers and acquisitions, that type of stuff, are sharing private market moving data, and we allow them to do it in a secure, auditable, and controllable manner. We do a whole bunch of cool technology, like encryption, bring your own keys, remote control of an HSM for your specific partition, and protection of files in use, where every downloaded file is encrypted with its own key, and you can email it to anyone you want, but they will not be able to open it because the key is at Interlinks. And I will mention this word once, a blockchain, because we're looking for a really good crypto engineer. But I'm not going to talk about these cool things. I'm going to talk about a very boring thing about application security. It's very hard to do, interestingly, and it has very interesting history, obviously, but we had to deal with it because our customers actually have the right to audit. They check our application. Some of them have seen our code. So as a matter of like, why are we having this talk? First of all, today everything is as code. Infrastructure as code, configurations as code, network as code. That means that all security issues potentially can be fixed in the code. And one other thing is that you can really start a good application security program without investing much money. And tools are not that important in the first stage. It's more important to have the commitment and actual processes how to fix the things you find. And then also, kind of contradicting myself, you really need some investments, smart investments, to get good tooling, good training, and actually establish a repeatable, good application security process. So as a matter of introduction, why is it so difficult, right? I mean, Dimitri was talking about Microsoft. I'm actually going to praise them. If anyone remembers what was happening in late 90s, early 2000s, there was a Microsoft security patch. There was usually some kind of buffer overrun, critical, and all of the IT system engineers were praying, including the atheists, because you install a patch and everything starts working. And at some point, they made a decision at Microsoft to make it a process, so they introduced and open sourced their secure development lifecycle, and it starts with you do the training first, then you come up with the requirements. At that stage, you set up your quality gates, you figure out what are the security and privacy issues you want to address. Then you go into the design mode. This is very important, obviously. You do the attack surface reduction, you set up your design requirements, threat modeling, obviously, and then after all that done, you go into the implementation stage. That's where you kind of use only the tools which are approved for use. You find what is unsafe and you get rid of that and perform your static analysis. You use some kind of a tool usually and find issues, you fix them. Then you go into verification stage where before you release or sometimes after release, you do the dynamic analysis, the fuzzing, and you actually review what's the real attack surface, right? And then you go to release mode. They talk about incident response plan. It's not really an application security task, so to speak, but it is obviously consideration. You do the final security review, approve, and it goes into production. And in like last step, you have the response. If something happens, you know how to execute the response. So that's kind of setting the stage, right? But in real life, it doesn't work like that. First of all, no one will tell you, okay, stop what you're doing, let's train everyone. Or you're not supposed to code if you don't have all of the requirements nailed down. And in real life, usually what happens, there is a coming of age stages. And at the first one, you just develop your cool application, it is in the market. You have some great customer. I call it the beginning state. It's a sincere ignorance. You're sitting there, it's warm and fuzzy. There are some rumblings you hear on that rail. You don't understand where it's coming from. You're still out there selling. You got your first big customer, and you're happy. And then what happens? The first assessment happens. And then you go into this vicious cycle. They do some penetration testing. They find some issues, and dozens of them are critical. You drop everything, you're fixing them, you're releasing them. By the time you do that, then there's a second customer who does their own assessment. And maybe the first one did another one, and they hired a different people who come up with different critical issues. And then you're chasing your tail kind of constantly. And this stage is a very important stage. This vicious cycle stage can turn into a death spiral, or someone will say, okay, let's stop and think about this. This is a problem. This is not a technical problem anymore. It's becoming a business problem because we're doing nothing more. We're just doing vulnerability report reviews and planning how to fix stuff. And that's where in good organizations, usually people start talking about, let's set up some kind of a process. And when you start this application security process, usually it's a painful kind of step where it's kind of you realize and you have to accept that whatever you were doing up to that point was not really working. You have great engineers, you have great talent, but it's very difficult to essentially make it a formal, repeatable process where, okay, you're not only responsible for making things that work, you're also responsible for trying to break it and making sure it doesn't break. It's kind of some contradiction in there. So, from my experience, I've spent over 20 years coding for financial industry, banks, financial institutions, stuff like that. Usually, in that process, you have tremendous pressures from outside, from your customers, and there is always a factor of what do I do? What is the right kind of first step? Because if you take that Microsoft approach, everyone clearly realizes it's not attainable. It is a mature kind of organizations process. There's also this difficult task of figuring out what is important, because typically if you do a penetration test, you get dozens of issues you have to worry about. And one of the recommendations is to do a static code analysis or something like that. And when you do that, you get now tens of thousands of issues to worry about. So there's this paralysis by analysis kind of a natural state. So it's very important to set up attainable goals, small ones, and then reach them. And this is like a first kind of inception stage where you set up small attainable goals and you achieve them and make sure it works and then move to the next one. So as a first attainable goal, it's like find your glaring issues first. And for that, you don't need to hire anyone. You can go get, I just listed a few free tools. You get the Zap proxy. It's pretty trivial to set up, and you have a few smart engineers that can figure out how to find, like, I don't know, you have a SQL injection on login page. It's not that difficult to find. And you better find it yourself, by the way, before anyone else. And essentially, if you're a startup, you're lucky because usually the customers are the first one who find it, not the attackers. But you can ride that luck just for so long. Someone who wants to do real harm can catch up very fast. And OpenSSL, the other one, if you just go to a website, plug in your web address, and it will tell you what's wrong with your SSL configuration, or TLS now. Essentially, find glaring issues, fix them. It will teach you a few things. I'll get to it a little bit later. And then you go from that stage kind of back into implementation. Now you found a few issues in the production and you know how to fix them. Now you can feel more comfortable finding issues and fixing which are under your own control. So if you're a developer, you don't need anyone to tell you that, I don't know, don't log this information to a console or to a file, or don't store passwords, or implement correct encryption algorithms, stuff like that. I listed a few tools. It is, again, my point is that you can do all of that without investing heavily into tools. These are all freely available. Those are all under Apache 2.0 license, so you're not obligated to do anything special in order to use them. Dependency Checker is a great tool. I don't know if you know about it. You run your software through it. It comes back and tells you that your engineers are using 200 different components that you have never heard of. And they're telling you, it tells you actually your risk exposure to unpatched versions of open source software. So if you're running Struts 2.3 something, it will tell you immediately that there are like 3 remote code executions right now in your production environment. SonarQube is the other one. My colleague will do a demo at the end if you have everything technology works. It's static code analysis. But it's not only that, it's a software quality management tool. It's, again, open source. It has great plugins. Java major technologies are built in. You can actually write your own if you want to. We've been using it for a few years. And I put there Claire last if you do Docker. It's a free tool, kind of give you a first feel of what to expect when a real kind of analysis kicks in. And timing is important also. SonarQube, just run it nightly. It doesn't cost you much, but every morning you will know what new issues have been introduced and which ones were fixed. And then after that, you fix some issues in production, you figured out some really important stuff in coding, and then you move on to kind of moving back a little bit. Now let's try to catch stuff before it happens, kind of. The threat modeling, again, I'm going to praise Microsoft again. It's a free tool. It's available. You do some very basic diagramming, pretty much, okay, these 3 components talk to each other, and this one goes over internet, and this one is internal. You plug in that information, it comes back and tells you basic stuff, like you need to encrypt this communication, you need to make sure that there is no repudiation, and all of that nice stuff. It helps you because it's very difficult to implement a major security control once you're in coding. It's just testing all of that. The verification phase is just too expensive to do. So this is kind of my 3 first attainable goals, which are easy to establish, pretty much free from budgeting perspective to do. However, it gives you some very interesting learning experience. And I call it like the Inception checklist. Those are a few things you can do without, again, investing too much money in it. First of all, we need to understand that all of those tools give you vulnerabilities, meaning this is something that may happen, or this is there. How to fix it is never usually in that recommendation, and the recommendation that they give you is usually not usable, like, I don't know, remove apostrophes in your usernames. It's like, okay, so all of the Irish are out. Or don't use this character, and this character is a currency denomination in some countries. So you cannot follow them. You need to do some investigation, figure out how to fix them. That's why it's really good. It helped us to have a special tickets which are called like vulnerability tickets, and then you create implementation tickets and link them back in so you can manage actually what's being done. Then another important thing is that get all stakeholders understand and agree what is critical, and then give a complete commitment to fix them within certain set amount of time. Set amount of time is important, what is critical is important. Because what sometimes happens in those situations, when you have 2,000 critical items, that means none of them will be fixed because there is no way to prioritize them. You need to agree that there are these few things that we absolutely cannot have. Like in our world, it is like we cannot have remote code execution in production. If anything like that comes up, we stop everything, fix that first. Nothing else is important. So that type of things. And when I say stakeholder, it includes everyone from support to sales to QA to development. Usually the committee is mostly product people, engineering people, and implementation, operations type of guys. But what is critical, it's important to have commitment from sales and support that, yeah, they will get in front of customers and kind of help you, because sometimes when you implement critical security fix, functionality suffers. So, but again, it's a business kind of decision. What's important, availability or confidentiality? In our world, it's confidentiality more important. But again, it's not one size fits all. And then the last one I said is a commitment to patch third-party components. This is very important to do in kind of a repeatable manner without involving too much of planning, because there are some patches that if they ask you what is the impact, you don't know. It's just someone tells you if you don't install it, something bad may happen. If they tell you what's the impact, how to test it, again, how to test the protection from remote code execution. There's no way to do that. So it needs to be some kind of a process that says if it is in this category, we're just going to patch it automatically and then let the engineers figure out if something breaks. So you do it in a lower environments, obviously, and then promote from development to production. So this, once you've done all of this, you have a pretty good initial security program. That means the drive-by hackers, the script kiddies cannot touch you, pretty much. I mean, but you're still going through growing pains. You're learning, essentially what this gives you is you're learning your process how to fix stuff. I think our industry is too much focused on how bad you are, kind of evaluations. And if 10 people are telling me I'm very bad, it doesn't help me. What helps me is what do I do about it? And this kind of initial steps gives you some learning experiences, learning opportunities to set up the processes to react to those. Because when the first time you install a struts patch, my favorite, since it has been very famous from last year with Equifax, the first time you do that, maybe you lose some functionality you didn't know, and maybe you learn that, oh, when I touch this component, I need to verify these things, and maybe you have some third-party integrator that you, as an engineer, didn't know they existed, that they're using these components, so if you apply this patch, they stop working. So this type of stuff to kind of learn as you go. It's also important for the engineering teams kind of being this habit of trusting security people. When they say it's critical, it is critical. Because, again, it's a very interesting dynamic when you go to a person and say, oh, great, whatever you were doing up to this point is wrong, and I'm going to tell you what to do. That's not a kind of right dynamic, and you need to establish that trust. And it's better to do that when you haven't spent too much resources into implementing some big vulnerability management program or some tool. They used to be, now they're more affordable. I come from a time where it was like $2,000 per developer. It was very, very expensive. So when you make that type of commitment, the tool kind of drives your behavior. I don't think that's the right way of doing stuff. Usually it's better when you figure out what works for you and then select a tool that kind of works in that environment. So once you have your kind of inception stage done, when you feel comfortable, and you have actually some metrics, you can go back and request some funding into your maturity and scaling stage. Now you're not, it's important, you're not reacting to some external event. You are kind of controlling your destiny. That's a very important dynamic again, because if you don't want to do something, you really don't do it well, right? So this is kind of, I'm doing stuff and now I want to do it better. I want to scale it. I want to do it everywhere. So I kind of call them maturity goals. I have about 4 of them. Goal number 1 is kind of move away from point-in-time assessment where once a year or, I don't know, once in 6 months, someone comes and runs this vulnerability scan, whatever tooling they're using, it's not important really, and then they tell you, oh, you have this, whatever, 2 criticals, 10 highs, and a few dozen mediums and lows, and then you fix them, and does it mean you're good? You don't know. Until the next year someone comes and tells you, no, you fixed this 2, but you introduce like 5 more. And then obviously the software grows, the versions grow, the competence of the hackers grow, so you end up kind of this vicious cycle that I had, but it's a little bit slower. You're not rotating that fast now, but still you're chasing your tail. So there are some tooling out there that allow you to do 24/7 dynamic assessment. Essentially, you give them all of your different users' roles. They have those users. They log in, whatever tool that is, automatically and try to attack you. And really good ones also have human that takes the report from that tool and kind of manually verifies those and reports back to you not the raw finding of the tool, but okay, this whatever 6 things, and this is how you can actually exploit this vulnerability. And we have a tool that actually gives you a number of attack vectors and say, okay, these 10 vectors didn't work, but the 6 did work, so you have to fix these things. And it gives you much more detailed information also, because at this point now you can consume that. Now you understand when someone tells you you need to fix I know, remote code execution in this and these places, or you need to fix some kind of a data tampering issue on specific APIs. And then it's kind of, again, a stretch goal. All the good goals need to be a little bit stretch. Try to implement the same thing before promoting to production, so you dynamically test your QA environment. And if any of you have done like third-party assessment type of situations, you know that it is a 4 to 6 week, a few dozen $1,000 engagements. Doing it on QA is usually not economically viable. That's why it's important to maybe use your free tools on the QA and then your commercial tools in production, something like that. So continuous assessment is very important in that maturity journey. Then after you configured and run SonarQube and you figured out like really big things that you want to fix, it's time to think about getting some commercial tool and use the extra bells and whistles that they provide. Some tools do license analysis for your open source. I don't know if it's important for you guys, but we have seen some what are called viral licenses. Essentially, again, no engineer thinks about it. There's a great component, he wants to use it, he gets it, it works great, provides the functionality you need, but then it's an affair license, which means if you use it, you have to open source anything that's using it. And just your great developer exposed you to some big legal issues, and you have a certain amount of time to rip it out and re-implement it or open source your stuff, which probably not a lot of people want to do. Non-patched components are another interesting output of those tools, which, again, the dependency checker will give it to you, but there are some commercial tools which are a little bit more sophisticated, and they not only tell you that this component has this many CVEs open on it, it will also actually report on a component which has no CVEs, but it's so old that you should think about replacing it. You'll be really surprised, I'm promising you, when the first time you run that, when you realize that you have a third-party component that inside it's using, I don't know, Java 3, and then no tool will report on it. No modern tool will report on it, by the way. because who looks for Java 3? But some of them actually do. I contradict myself there. But my point is, once you know those issues, commercial tools will have proper reporting and will allow you to do full tracking of issues and all of that. This is a time to do that. And the important thing there is, for nightly build analysis is not good enough. Now you want to do it for each build, because especially where the technology has shifted dramatically with the microservices and all of these different teams collaborating, it's very important to catch issues very, very early. And I'll talk about it a little later, when you want to break the build as fast as possible if there is any major security issue in it. So when we've done this commercial code analysis tool integration, now we move on, which actually shifting left, going back into requirements phase. Now, I was talking about failing builds. Now is a time to think about what criteria makes this build absolutely unusable from security point of view. I would say like a fair license will be one. It should not go in production. Again, it's CI/CD kind of situation. You want to make sure that things don't slip out. Or in our world, remote code execution cannot go out. Or if it is, by the way, those security gates can be in many different places. It can be on configuration, it can be on third-party components, it can be actual code itself. If, I don't know, some static analysis tools will find that your password is hard-coded somewhere, or there's an encryption key in the code, or somewhere in the configuration file. So those things absolutely have to fail the builds. And the best way of getting engineers' attention is actually failing the build. Everything else doesn't work that well, I'll tell you from my own experience. Once we have the security gates, now it's time to think about actually training people. So remember that Microsoft SDL that starts with training, in my opinion and in our experience, actually you start training people only after all of those things are done, all of the tools are established, the processes are established. Now, some tools actually do the training, like tell engineers what is wrong, but now you have to have a formal one. And I really recommend to do like recertification every year, because again, technology changes, teams change, people change positions and all of that. So you better be prepared to do that. I don't have any free training programs, but the paid ones are not that expensive, so it's a very good investment to do that. Also, what you will learn, and people will tell you that security people are hard to come by, and that's true. So especially application security is not as interesting as hacking or breaking stuff and getting credit for that. This is like everyday hard work with very few credits. So you need to find a way of scaling through deputizing people. We call them security champions. We train them and we try to make them present in every Scrum team so they can represent the security view during these discussions. And again, the closer you are to the actual implementation teams, better the chances that the mistakes will not be made. So this is my maturity kind of set of goals. And this is the checklist I came up with. It's very important to have this cross-team committee to review security issues. Because at the time you make the decision, you want to have the voice of everyone heard, the operation folks. You cannot have a situation where you're telling them, okay, you need to, I don't know, reinstall certificates every 10 minutes. Maybe it's feasible, maybe it's not, who knows. But you need to have that person there, because once you made a decision, you commit to the time, and then sometimes at the end of the cycle, someone comes and says, oh, it's not possible to implement operationally or some other way. So it's important to have this committee which meets at some regular basis and reviews those issues. It's very important to establish timeline to fix all security issues, not only criticals. And there's a very good reason for that. Number one is, especially in financial industry, the way people consume your services is not as straightforward as there is a business user, they buy it, they use it. They have to go through your internal risk committee approvals. And usually what happens, you make the sale, it goes to the risk committee, they come back and tell you you have these issues, you have to fix it, you fix it, but internally this business guy has to accept some risk, because there's no way, however great your application is, there is a time and resources to fix everything before it goes into production or use, right? So essentially what happens, they sign up for it, they say, well, this vendor is good, they committed to the timeline, I'm good. And then what happens, a year passes, and an issue that was reported as medium, which has a time to fix as, I don't know, 6 months, let's say, and they say, it's okay, 6 months is good. And then a year passes, you haven't fixed the medium one. It goes back to them, and they say, oh, now you have an issue which has passed its SLA. Now it's a high issue. And now your business guy, he likes your product, wants to pay you and pays you, has to go to the risk guy and pretty much ask forgiveness. And the way it works in those more regulated industries, every spiral you have to go higher. So first time you sign off, next time your boss has to sign off. So essentially, by making an engineering decision of, oh, this is medium, it's okay, you're putting a business guy in a very bad spot. You don't want to do that with your customer, because he's the guy actually who's advocating for it. He's the guy who pays you. That's why it's important to agree and follow this. Okay, if it's low, okay, 1 year, great. Fix it in 1 year, but make sure you fix it. I talk about patching a lot. Automate it. It's very important. It's kind of self-explanatory, and I'm not going to talk about it too much. Establish metrics. Measure what you're doing. And make sure you can communicate it to people who invest money in. Essentially, you go back and ask for budget, right? You have to, and this idea was kind of, I heard about it yesterday too. It's kind of a universal. You have to show what you're doing in order for people to give you resources to do something, right? So it's very important to determine what is important to your own business, to your own situation, to communicate to the executive level management that, okay, this is the budget, we need to achieve this goal, and we have this budget already, and this is what we did. We, I don't know, fixed this many issues. We were this fast to react, all of that. So that's kind of covers what I was intended to present to you today. The conclusion is a little bit long, but I'm kind of going to reiterate about this customized SDL steps. So you don't start from training, obviously. You start from production scanning. Then you do your code analysis, then do the threat modeling. That's your kind of infancy stages of your security process. You do that, you're ahead from a lot of people, unfortunately. But again, you're in a good place to really start to institutionalize application security within your development organization. So, and then you go in your maturity steps, your continuous assessment, your automated code analysis, security gates, and training. And I will finish with actually talking about the training part. Ultimately, people make this thing work. Okay, you need the buy-in from a lot of people, from everyone actually. But there is a growth process. First you get this visionary who brings you to the edge, but makes sure you don't fall off the cliff. You need that person. It can be a committee, but you need that kind of concept, that someone who owns, who's passionate enough, knowledgeable enough to kind of start this process. Then it's kind of spreading through the organization, helping each other to achieve the same level, kind of. Because it makes no sense to have great code and then deploy it in a very vulnerable manner. It has to be kind of same level. You have to bring up other people to that level. And then you proliferate as much as you can across different teams, that people help each other to kind of get there. And this is my favorite picture. Everyone has to participate. And when I say everyone, I mean everyone. Because our technology stack is so complex today that you don't know where the big vulnerability will be. We've gone through over 300 probably assessments across the world. French companies, Brazilian companies, US companies doing that. And after that, we do the 2 different commercial scanning, dynamic, static, open source. We do this threat modeling, everything, and we still find issues. So you need really everyone's commitment to get to the very nice level. And at the end, I have some links that are in the presentation, is probably on the website you can use to get the tools, which are, again, those all are free. We have used a few of them. A few of them we just evaluated, we didn't use, and we may not use. But I cannot say enough praise for SonarQube. And the way we introduced it was perfect too. I had a principal engineer come to me and say, hey, Mush, I found this great tool. I said, what the hell is it? Oh, Sonar, it does static analysis. And then we started, and essentially it came from engineering a few years back, and it helped us a lot. And just that as a matter of reference, after 2 years of running Sonar, when we did the first professional commercial tool assessment, there were no highs or very highs. There were only mediums. The highest reported issue was medium. So it really works, just spending no money, just with some commitment and some work to get to the great level. And that's pretty much it. My colleague Bogdan will do a demo for SonarQube if you're interested. And then we'll have some questions.
Hi. Do you like this? Hi, so I'm Bogdan. I'm going to demo SonarQube. Yeah, this is better.
Okay.
Yep. You can see my screen? Yep. Pretty long one. Yeah. I have here an installation of SonarQube. It's the community edition. It's free to use on your commercial projects. As my colleague Mush said, SonarQube can really help you with your code scanning. It's not only about security. It can cover aspects like bugs, performance issues, coding idioms, and stuff like this. The main idea behind SonarQube is the scanner, is the plugin system that can bring you scanners for your languages, your coding languages, and it can bring you rules. Basically, rules cover all the aspects of coding. You can see here there are bugs, vulnerabilities, code smells, security hotspots, and so on. They are grouped into different layers of severities, from blockers to info. And you usually have to define quality profiles here for your scanning before starting scanning the actual projects. SonarQube usually comes with predefined scanners, but I already defined two quality profiles for Java language because we've picked a Java project. One is a more stringent one, DefCamp demo one, and another one is a more filtered one. You'll see why I've made this choice. I also defined a quality gate for my build to fail when I will integrate this into a CI/CD pipeline. And I say that I do not like blocker issues. So basically, this will break the build, you know? The project we've picked is one very dear to us. It's Struts 2, you know? We've picked this up. And with the initial profile, DefCamp demo 1, that I've set up, we had like more than 2,800 blocker issues. Now, what's a blocker? That's something that has to be decided by the security architects, by the architects, and by the teams. You know, there has to be a meeting where people discuss what issues are actually critical for you and what issues you can postpone and fix later. So in the case of the first rule, we have these 2,800 blockers. We cannot fix them, actually. I mean, you cannot wait for the actual business requirements. You cannot stop them, their implementation, and fix these security defects. So you have to filter a little bit more. That's what I did. So that's why I defined the second one, the second quality profile, DefCamp demo filter. And here you can see I applied it to the Struts project. Now, let's go back. There are 500 blocker issues. We can filter it a little bit more. Let's see what those issues are. I can expand here on the rules, and it has a nice grouping. The most occurrences, 87 classes should not be loaded dynamically. The issue usually is defined, the severity is critical, but in this profile, we've made it a blocker because we do not want to have this vulnerability. For example, let's pick another one. Standard outputs should not be used. So this is basically logging to console. I've marked this as a blocker issue. Initially, it was a major one. Now, judging by the number of blocker issues, more than 500, we can say that we can minimize the actual severity of this issue. Yeah, we can go here, and you can see here is the actual rule. It's made a blocker. I can minimize it. From blocker, I can make it again a major issue. And for the time being, we can say, hey, we don't care about this rule currently, fix the other issues. Another interesting one, catching generic errors. That's not very helpful. Using assertions that can be easily stripped out at compile time, you know. Closing resources, yep. And try with resources. So from those 500s, you can easily go lower and still have, let's say, a subset of 100, 200, 300 issues that can probably be fixed by your development teams inside the sprint, and then you can pick more. One last thing I'd like to show. Sonar has a web API, a REST API. We are using it. You can actually use it to do a whole lot of stuff automation stuff. You can use it for reporting. You can use it to grab data, to build those metrics for the committee, you know? That's pretty much it.
Okay, thank you very much for the demo and
Thanks,
for the
Bogdan.
presentation. We're now ready to take questions, so put your hands up and please stand so we can see you. We have one over there. A mic is coming to you. Please keep your hand up. Just a second, sorry. You will get to see your question, we promise.
Hey.
Now you have both.
Okay. Okay. So you talked about a lot of software development after you have the code. What do you have to do to start out with the idea that I'm going to make a secure software, and what are some pitfalls you usually see in code?
Sorry, from the beginning, you mean when?
Yeah, in the design stage. So let's say you start out with the idea that you're going to make a secure software that also does X.
Okay, so
what are the requirements you go through, or some pitfalls, or some or tendency of developers of using old code or stuff like that?
Right. Thanks for the question. Great question. So there are two levels to it. One is, like you mentioned, the third-party components. You should absolutely start with dependency checker. Make sure that in 2018 you're not including a version of Java from 2004. So that's absolutely, there is no good reason of doing anything like that. So the second one is, it sounds intimidating, but threat modeling is absolutely essential when you do the first implementations. Essentially what you're doing is you're going to ask a few questions to business, like what are the regulatory type of requirements for this software, and if it's a startup, it's probably you're asking yourself. And once you decide that it is, let's say it's in the financial technology or it's under, I don't know, European GDPR controls, something like that, that gives you a very high level framework type of requirements. If you're using any type of crypto stuff, I recommend go read the NIST documentation. They're getting better and better and smaller. So that's very essential. So I would say like this, three things. One is make sure your components are up to date. Two, make sure you do threat modeling as fast as you can, as early as you can, and understand where it's going to run. Doing all this static analysis, all of those things is probably going to be too much of an overhead at the beginning. But you kind of assume that developers are kind of knowledgeable in making good software.
Great. Do we have another question over here?
There's one there.
Okay. So you demoed SonarQube on Struts 2. Is it written in Java or in another language? And can you find vulnerabilities in languages such as Lua or some scripting languages as well with SonarQube or with some other tool from the ones you mentioned?
Sure. Yeah, we did Java by default. It kind of comes in pre-installed. Later on, we introduced, we do JavaScript hacking. Freudian slip, right? We do JavaScript analysis, and it's important, very important in JavaScript. We had to have two different profiles for ES5 and ES6 because we had different, like, big framework components, which if you put under ES6 requirements, it will never build because it has all of these variable declaration issues, all of that. So yes, there are free plugins for JavaScript. We do .NET technologies. I think there is like Python, pretty much anything you can think of, there is a plugin, and majority of those are free.
One last question here.
Did you try analyzers like checkmarks or Caverity, and what is your opinion about those analyzers?
First I decided not to talk about products, but we don't use any of those two. We use a different vendor. And what I found out is there is always a delta between those tools. So I would focus more on how convenient it is for you to use it, the tool itself. And then once you have the process established, then you bring in another do a trial of another tool. And we're investigating technologies that allow you to do it live. Like you can run your own scan and then bring in a trial version and compare those two scans. So it will tell you what the difference is. I personally have no preference. As a historical reference, we've evaluated early on that Veracode for the Ounce Labs Clockwork. Then there was my favorite one. Now it's an HP company. Oh God, that.
I'm sure you can catch up during the break. Don't worry.
You know that. Anyway, I remember and tell you. So we went through 4 of them, and the deciding factor was how easy it was to integrate with our own processes.
Awesome. Thank you very much for your presentation, for the demo, for answering all these questions.